Assalamualaikum and selamat sejahtera. In this video, we will discuss DC voltage regulation using DC-DC converters, or also known as DC-DC choppers. There are three types of DC converters, which are buck converters to step down the input DC voltage, boost converters to step up the voltage, and buck boost converters to perform step down and step up functions. Regardless of different functions, each DC converter requires energy storage, which is an inductor, to operate efficiently. Other than to act as energy storage, the inductor also works as a current filter to ensure continuous and ripple-free DC current flows to the DC load. In the next explanation, we will look in detail about the inductor roles in the operation of each DC converter. Lastly, to maintain continuous and ripple-free DC voltage across the load, a capacitor is used as a voltage filter. Typically, the capacitor is connected in parallel to the load. In the next explanation, we will neglect the role of the capacitor while discussing the operation of the DC converters. Later, when we discuss the design procedures of DC converters, we will consider back the role of the capacitor. I will use the water distribution system as an analogy of the operation of DC-DC converters. Based on the diagram, the self-generated utility water tank represents the input DC source of the converter's circuit. Next, the consumer tank represents the DC load, which is a resistor in the circuit. In this system, the water-generated tank can generate water when there is a water flow. This tank acts as water storage of the system. Hence, this tank will represent the inductor because the inductor will store magnetic field when there is a current flow through it. To let the tank to generate and store the water according to the consumer demand, a controllable power switch is used to regulate the operation of the tank. In the DC converter, a transistor such as IGBT, BJT, or MOSFET is used as the controllable power switch. Once the tank stored enough water, the controllable switch must be turned off. When it happens, automatically another switch is turned on to maintain the water flow between the water-generated tank and the consumer tank. This switch cannot be controlled, and it will turn on whenever the controllable switch is turned off. In the DC converter circuit, a diode is used to maintain the connection between the inductor and the resistive load. As a conclusion, other than the capacitor, each DC converter circuit must consist of the input DC supply, resistive load, an inductor, one controllable power switch, and one diode.